So today, I had something cool that I wanted to show you. On the periodic table, which is right here, these guys are the alkali metals. They're solid and they're aggressive. Because they have one valence electron, they're so close to being stable, they will give that electron away to anything, like almost forcibly. So these are silly reactive. And I have 3 I'm going to show you with today. Just to kind of put it into reference, these are the halogens. These have a -1 charge and gas, gas, liquid, solid, making it one of the more interesting columns of the periodic table, and honestly my personal favorite. Here, these have 7 valence electrons and want to gain 1, and they will do anything to gain 1. So these are equally as aggressive as these. But because these are more solids and these are more gas and liquid, it's easier to control these. We're going to focus on these today. So coming back to kind of what you saw at the beginning here, this is a piece of lithium metal, sodium metal, and potassium, which again is the first 3 alkali metals on the periodic table. Again, doesn't maybe look like a metal like you would think, but check this out. You would think a metal would be really strong, and I, with very little back and forth effort, I'm just going to try to fan it to show you guys, can split it open. I don't know how well you can see that, but there's definitely more of a silver gash right there. Again, I'll try it one more time just to open it. This time I'm going to put a lot more pressure on. Again, it's cutting actually really easily. And you can see the silver on the inside. This, because it's reactive, that's actually going to rust really quickly. Check this one out. This one, even softer, I cut this whole piece in half. And you can see the exposed shininess in the middle there. This is sodium. Now potassium comes inside this metal container that's filled with gravel. That's how reactive this is. I haven't even opened this one yet, for safety reasons. It also, if you wanted to look inside, much smaller pieces. There's no piece that size in there. And again, I'm just going to take the smallest piece possible. Again, it's very, very soft. Incredibly soft. Like, there's no effort at all for me to cut this piece in half. No effort at all. And again, I'm just going to put this back in to get that away. So, let's see what we put them with water. So, what I'm going to do is I'm going to get a very small piece of this. And again, I'm going to be putting this piece into water. Let's see what happens. And note, this is just regular water. You notice that it's hissing pretty good, and it's reacting with the water, even producing smoke. Now, I'll be honest with you. I put a chemical called phenolphthalein in here, and it tells if something is a acid or base. So, alkali in Latin means base. So this pink color is because lithium is a basic metal. Now, I have an acid in here. Actually, a very, very common acid. To give you a hint, it's in hot sauces and has a very distinct smell. If you didn't figure it out by now, that was a little bit of vinegar, just household distilled vinegar, and we were able to reset it. Let's look at the sodium. And again, I'm going to do a smaller piece than that just for safety reasons. That kind of gives you a hint of what's going to happen. Again, sodium with water. Did you miss it? Actually, that's pretty cool. With the tornado, that's pretty cool. And again, thank you to my camera lady, Mrs. Servos here, for helping me out. I'm going to do another piece. But again, don't blink. Again, that's much quicker. It sounds much more aggressive than the lithium. I'm going to do one more piece. You can see how it's becoming spherical. And again, same thing as before. I'm going to keep that there. We're gonna add a little vinegar just to get it back to clear. That might not be enough this time, we'll see. Because I added a lot more. Oh, we're fine. It's a little magic trick at parties. And you can actually see at the bottom here, there's a little bit still left because you can see the purple trail. But it is starting to go away. And then we have potassium. Potassium is a lot more reactive. So you might want, I would probably... Oh, yeah. That's cool. A lot more smoke, and you saw that actually caught fire. It caught fire when you touched it with water, which is really crazy if you think about it. And again, this actually looks like I added too much vinegar, because you can see how easily this is changing back. And I have one little piece of potassium left, very small. And I don't know, actually off camera, I touched it with this and actually caught fire and already reacted on here. It actually already is gone. Because this had to have a little bit of water on it. There's the only way that could have occurred. But I'm gonna try this just to see. Yeah, it reacted with that. But there is some of the alkali metals. We don't have rubidium and cesium because they're even more dangerous. So, we'll stop it here. So, next time you're wondering what the heck valence electrons and charges, that's what that means. So, you don't want to play with these.